Hello everyone. Now I'm going to explain limits of trigonometric functions at positive or negative infinity. So when we solve questions, there are some things you need to know. For example, limit at infinity for sine or cosine function does not exist because the function oscillates between two fixed numbers. So whenever there is limit as x approaches to infinity of sine or cosine of something, then the limit does not exist. Another situation you need to know is limit as x approaches to infinity of sine or cosine over x will give you 0 because of the squeeze theorem. So let's take a look at questions. First question, check it out. 7. Find each limit. Limit as x approaches to positive infinity of cosine x. When you insert infinity for x in the function, you are going to have oscillating behavior, so limit does not exist. Oscillating behavior. Second situation, limit as x approaches to cosine over x is equal to 0 by using squeeze theorem. Let me prove this once and I will not do this again. So remember, cosine x, the range of cosine or sine is between negative and positive 1, right? Here I have divided by x, so divide everything by x. And remember how to do squeeze theorem. You take limit of each side. Limit as x approaches to positive infinity of negative 1 over x is less than or equal to limit as x approaches to positive infinity of cosine x over x is less than or equal to limit as x approaches to positive infinity of 1 over x. Now, when I insert infinity back here, 1 over infinity, number over infinity give me 0. On the other side also, 1 over infinity, number over infinity gives me 0. Since right side and left side are both 0, then limit as x approaches to infinity of cosine x over x or sine x over x will also be 0. So by squeeze theorem, these kind of limits will be 0. And there are some other types of questions, of course. We can solve it by just using direct substitution. When you insert infinity back, it's not cosine infinity. If it were cosine infinity, it would be does not exist, oscillating behavior, but it is cosine 1 over infinity. What is 1 over infinity? Number over infinity is 0, so we are looking for cosine 0, which is 1. So be careful, there's a division here. It is not just infinity, it's 1 over infinity, so it changes the result. There are other types of questions as well. Using direct substitution will not give you anything, because when you substitute infinity here, you'll have infinity plus sine infinity, which does not exist. Infinity plus does not exist. What is it? We don't know. So we have to rewrite the function for the questions that we don't have an answer, a direct answer. So rewrite the function. How do you rewrite the function? When we rewrite the function, we divide everything by the highest power of denominator, which is x. So distribute the limit. So it's gonna be limit as x approaches to infinity of 1 over x over limit as x approaches to infinity of, when x is cancelled, there is 2 plus sine x over x. Now evaluate each limit separately. When I insert infinity back, number over infinity gives me 0. When I insert infinity here, I see sine infinity over infinity, which is 0 because of the squeeze theorem. Limit as x approaches to infinity of 2 will be 2. So we have 0 at the top, 2 plus 0 at the bottom, which is 0. Okay. So whenever you don't get the answer immediately, you divide everything by generally x, by the highest power of denominator. Let's do one last question and finish the lesson. Which one is true? A mystery question. When I insert infinity back, I'll get infinity over infinity, which requires using L'Hopital's. Let's use L'Hopital's. So when I do, I'll get 2 times 2, 4x, minus 1 over minus 1. So let's take limit of this result. Inserting infinity will give me infinity over negative 1, which is negative infinity. So option A is false. Option B, I have inserting infinity gives me infinity divided by cosine infinity plus infinity. Infinity divided by does not exist plus infinity, which gives me nothing. So I have to divide everything by x. So it will be limit as x approaches to infinity of 6 at the top. At the bottom, cosine x over x plus 3. So here I see 6 at the top, 3 at the bottom, cosine x over x is 0. So 6 over 3, which is 2. So it seems option B is true. Option C, why not? It's false. Why it is false? Let's see. Okay, when I distribute this, I'm gonna get 9 minus 12x plus 4x squared. I have the same coefficients. I have the same degrees, so I can take the coefficients, the ratio of the coefficients to get the limit, which is 4 at the top, 3 at the bottom. So it should be 4 over 3, not negative 2 over 3. So that's also false. Option D, I have infinity at the top, does not exist at the bottom. So I should rewrite the function by dividing top and bottom by x. So when I rewrite the limit, it's gonna be limit as x approaches to negative infinity of 1 at the top, at the bottom 2 sine x over x. So I see 1 at the top and sine x over x, limit as x approaches the infinity of sine x over x is 0. We have 2 in front, so 1 over 0, which is undefined. So this is not true either. My correct answer is B.